their sensitivity to sucrose or to glucose. They were just as good at TER 8 as they were at TER 1. The difference is not statistically significant. With sodium chloride, we did get a significance at the 5% level, but that simply tells us that the highest one is significantly different than the lowest one. Here's the highest one, and here's the lowest one. They were better on the third one than they were on the first, but then this stayed high. And citric acid, we found that the more they tasted, the better they got. The highest one is up at the 8th pair. So this is how we determine how many samples to give a person at one sitting. We want to give them the maximum number possible so that you have the most efficient situation. You get maximum data for the same unit time without minimizing the responses that one would get. We were conducting a study over a 9-month period, 8-month period, and we found that in October, when we first started the study, that here was their sensitivity, and by May, here was the sensitivity. The sensitivity to sucrose and glucose decreased in May, to sodium chloride increased, and the citric acid increased. So, and these were significant changes, as you can see here. So they didn't get tired and decide to drop off, or they didn't improve tremendously. It seemed to be specific for the taste that we were looking at. Yeah.
On that last one, do you think weather had anything to do with it?
Weather?
Yeah.
I don't know. This is in Davis, and you have good days in October and terrible days in May, and vice versa. I don't know whether the thermal effect, if it were temperature, you know, like we had a cold or wet December, then why would it be selective for citric acid as compared to sucrose and sodium chloride? I don't know. I can't explain why this happened. Why would have one increase and another one drop off? And finally, I want to illustrate the effect of the method that you use on the taste responses you would obtain. We wanted to know what happens if you increase the acid, what happens to the taste of a sugar solution. And we found that the taste of the sugar solution is decreased if you increase the acid. But you see the magnitude of the decrease? It just barely does. In fact, some of them don't seem to change much at all. Okay, this is using a single sample presentation where one sample is presented and you're asked how sweet is it. If we take the same concentrations, and this time they are compared with a distilled water blank in a paired comparison, then we get data that look like this. Now there's no doubt in a paired comparison that as you increase citric acid, you get a decrease in the responses to sugar solutions. So this is one of the reasons why we contend that a paired comparison is much more sensitive than single samples. And you can see how this is true. It's easier to make relative judgments than it is to make absolute judgments. The same was true for other types of compounds. If we use lactic acid or tartaric acid or acetic acid or citric acid, it didn't make any difference. As long as you increase the acid, you reduce the sweetness of all concentrations of the sugar solution. Okay, what happens if you play around with salt and sucrose? In a single sample presentation, there is a decrease, but you can see that the lines are pretty flat. Now take exactly the same situation and put it in a paired comparison. This is single sample, the next one is paired comparison. Now there's no doubt. As you increase sucrose, you depress the saltiness of sodium chloride. As you increase sodium chloride, you decrease the saltiness of sucrose. So we find, just to summarize in general, if you add one taste to another, they usually have a mutually masking effect. One reduces the taste intensity of the other. There was one exception, and that was this one. When we added citric acid to sodium chloride, half of the people said it decreased the saltiness, and the other half said it increased it. So you can see what would have happened if I decided just to present an average. We would have had something that comes along here. This is a bimodal distribution. There was nobody in between. They say it either decreases or increases it. So I thought there must be something to do with the method. So I tried another method. This one is a preference method. If you get this one versus this one, which do you prefer? This one versus that one, everything against each other. Then I plot the frequency of the preferences, and I found that the same people on the previous chart that went up, they're these people here. They go up, some drop down eventually. Those on the previous chart that went down, they're the same people that go down here. So if I changed the method, they gave me the same answer. if I change the material, so I try to find something else that's salty, and I can't find another salt that is salty, a very highly purified solution of monosodium glutamate is primarily salty. And here I found that they disliked them all. They dislike this is a neutral point of neither like or dislike. They dislike everything. But the people that disliked it the most in the previous slide are on the lower end of the scale, and vice versa. So the people are very consistent. So in summary, I tried this effect of acid on saltiness. I tried it in lima beans, tried it in green beans, and I tried it in water. And these were the small number of people I had, since I didn't anticipate it in advance, and the study was going over a 1.5 year period. And if they went up, which means that they think that acid enhances salt, I called them plus. If they did the opposite, I called them minus. Now one thing you notice that the minus judges are always minus judges in all three media. Plus judges are always plus judges in all three media. There was only one person that flipped. Here, he said one thing in water and something else, and we're still in lima beans. And we found that whether he was negative or positive on my scale here had no relationship to age, sex, smoking, time of day, or anything else I could measure. But I'm talking about a very small population here. So maybe some of the causative factors would be lost because the population isn't large enough. What happens if you combine a taste with alcohol? One of my graduate students had the unpleasant task of doing her research on alcohol, and she found that when you increase the amount of ethyl alcohol in solution, going up to 24%, this is a pretty stiff drink at 24%, she found that bitterness is enhanced, saltiness is depressed, sourness is very definitely depressed, and sweetness is enhanced. In other words, alcohol enhances bitterness of quinine and the sweetness of sucrose, but it depresses the other tastes. What happens when you smoke? We tried one study where we had a person smoke a cigarette after he did a test and then take the test again after smoking. So we had before smoking and after smoking, how sensitive the person was to these materials in solution. The non-smokers did the same thing, except they didn't smoke. They had a set of solutions to taste it, then they waited about 5 minutes and they came in and took another set. That way I would know the time order effect. The only thing that came out significant has a star. This says that for sodium chloride, after smoking the cigarette, they were significantly more sensitive for sodium chloride. The 82% is significantly different than 78. And over here it says that for citric acid, on the second set, they were more sensitive than they were on the first set. But the effect of smoking, this was the odor of vanillin, the odor of butanone, and this was the viscosity of a gum solution. So I don't know that we have contributed anything about smoking. All we can tell is that we don't think it's too important whether or not a person smokes before they come in to taste, if this is the sort of thing that we get from them. Oops. I think I'll finish with this one. When we conducted the study among prisoners at Vacaville at the California medical facilities, we had 45 smokers and 45 non-smokers. And in addition to measuring their taste sensitivity, we asked them questions about their food consumption, and this is what we obtained. The smokers, they smoked an average of 28 cigarettes a day, and the non-smokers had never used any tobacco products. And the only thing that came out significant was their degree of liking for coffee and for beer. And we find that the smokers like coffee significantly better than do the non-smokers, and in addition, they drink significantly more cups a day. I guess that makes sense. They drank almost 7 cups a day, whereas the non-smokers averaged 4 cups a day. And the response to beer is that the smokers liked beer better than the non-smokers did. But it didn't work out with any of the other things that we asked them about. And there had been previous reports in the literature that smokers have a tendency to be large consumers of alcoholic beverages and of coffee. There seems to be some relationship between smoking a cigarette and drinking a cup of coffee. Okay.